Starting an engine on a frigid morning feels like a mechanical protest. You turn the key, and instead of a clean, crisp ignition, you get a slow, groaning crank. The engine struggles against the cold, thick oil and the sheer thermal inefficiency of it all. It's a moment every vehicle owner in a cold climate knows well. To solve this, engineers have developed two primary strategies: the engine air heater and the coolant heater. Understanding the distinction isn't just academic, it's about choosing the right tool for the job, whether your priority is a quick start, long-term engine health, or simply a warm cabin waiting for you. What they heat. Here's the core distinction, and it's the most important one to grasp. An engine air heater, true to its name, focuses exclusively on heating the air entering the engine's combustion chamber. In a diesel engine, where combustion happens through compression, cold, dense air can prevent the fuel from igniting properly. The air heater, often a grid of resistive wires in the intake manifold, acts like a toaster, warming that incoming air just enough to facilitate ignition. It's a highly targeted, almost surgical strike of heat aimed at one specific moment in the engine's cycle: the start. A coolant heater, on the other hand, takes a completely different, more systemic approach. It is plumbed directly into your engine's cooling system. Its job is to heat the engine coolant, the same fluid that circulates to prevent overheating during normal operation. As the coolant warms, it circulates through the engine block, either by natural convection, a process called thermosiphon, or with the help of an auxiliary electric pump. This warm coolant transfers its thermal energy directly to the metal of the engine block, the cylinder heads, and everything else it touches. Primary use cases. Because of what they heat, their applications diverge significantly. The engine air heater is almost exclusively a tool for diesel engines. Diesels rely on high compression to ignite their fuel, and extremely cold air can make this difficult or impossible. Therefore, an intake air heater, or its cousin, the glow plug, is a starting aid, pure and simple. It's designed to overcome that initial hurdle of a cold start in a diesel. You'll find them standard on many diesel trucks and heavy equipment designed for cold weather operation. Coolant heaters, by contrast, are versatile and used on both gasoline and diesel engines of all sizes, from passenger cars to massive generators and commercial trucks. Their use case is much broader than just starting assistance. A coolant heater is for anyone who wants to reduce the overall stress of a cold start. This includes preheating the engine to reduce wear, improving fuel economy by avoiding a long, rich warm-up idle, and, as a very welcome side effect, enabling nearly instant cabin heat and defrosting capabilities the moment the engine starts. Warm-up behavior. The perceived speed and effect of these two heaters are worlds apart. An air heater's effect is immediate but narrow. It works during the cranking phase, heating the air just as it's being drawn into the cylinders. The engine either starts cleanly or it doesn't. Its job is done the moment the engine is running on its own. You get a quick start, but the engine itself is still stone cold, and you'll have to wait for it to build heat naturally to get warm air from your vents. A coolant heater's work is done before you even get in the vehicle. You typically run it for an hour or more before you plan to leave. The warm-up is slow, gentle, and comprehensive. When you turn the key, the engine starts as if it were a mild spring day. The oil is warmer and flows more easily. The tolerances between metal parts are closer to their normal operating state, and the whole system is just happier. The difference is not just in the easy start, but in the immediate aftermath. Fuel and energy impact. Here, the trade-offs become clearer. An engine air heater is an energy miser. It's a high-draw device, but only for a very short period, typically 15 to 30 seconds during the pre-start and cranking phases. It draws a heavy current from the battery, but its total energy consumption is quite low because of the short duration. It's an efficient solution for its very specific problem. A coolant heater is a different story. It's a marathon runner, not a sprinter. Whether it's a 120-volt plug-in block heater or a fuel-fired heater that burns a small amount of gasoline or diesel from your tank, it's designed to run for an extended period. A typical plug-in heater might draw 750 to 1500 watts, and you might run it for several hours, which will be reflected on your electricity bill. Fuel-fired heaters sip fuel, perhaps 1/10 of a gallon per hour, but that adds up. However, this upfront energy cost is offset by significant gains after the start. A preheated engine runs more efficiently and reaches its optimal operating temperature faster, which means the ECU can lean out the fuel mixture sooner, reducing the fuel-rich warm-up phase that wastes gas. Engine wear and longevity. This is where the coolant heater truly shines and presents its most compelling argument. The vast majority of engine wear occurs during a cold start. When an engine is cold, the oil is thick and viscous, like molasses. It doesn't circulate quickly, leaving critical components like bearings, camshafts, and cylinder walls relatively unprotected for the first few moments after ignition. This is a period of high friction and metal-on-metal contact. An air heater does absolutely nothing to mitigate this. A coolant heater, by warming the entire engine block, directly addresses this problem. As the block warms, it radiates heat to the oil in the pan, making it thinner and allowing it to flow much more quickly upon startup. The metal parts are also closer to their designed operating size, reducing piston slap and other sources of wear. Bottom line, starting a preheated engine is mechanically far gentler. Cabin heating. For many drivers, this is the most tangible and appreciated difference. An engine air heater has zero impact on how quickly your cabin gets warm. Your car's heater works by passing hot engine coolant through a small radiator called a heater core, and a fan blows air over it into your cabin. If the coolant is cold, the air is cold. With a coolant heater, the game is completely changed. Because you've preheated the engine coolant, the heater core is already warm the moment you start the car. You can turn on the fan and get useful heat almost immediately. This isn't just a creature comfort, it's a safety feature. Being able to clear an iced-over windshield with the defroster in a minute or two, rather than waiting 10 minutes while scraping furiously, is a massive advantage on a winter morning. Installation and complexity. Generally speaking, an engine air heater is a simpler device. On diesel trucks where they are common, the grid heater is an integrated component of the intake system installed at the factory. Aftermarket diesel air heaters designed for cabin heat are also relatively straightforward, requiring only a fuel line, an exhaust pipe, and ducting for the air. Coolant heaters are inherently more complex to install because they must become part of the engine's plumbing. The simplest type, a frost plug heater, replaces a metal plug in the engine block and can be difficult to access. Tank-style heaters need to be mounted in the engine bay and have hoses running to and from the cooling system. Fuel-fired heaters are the most complex, requiring integration with both the cooling system and the vehicle's fuel and electrical systems. Maintenance and reliability. With simplicity comes reliability. An intake air heater has few failure points. It's essentially a large resistor, and while the control relays can fail, the heater element itself is quite robust, though it can suffer from carbon buildup over time. A coolant heater, with its extra hoses, clamps, and in some cases circulation pumps, introduces more variables. Coolant hoses can perish, clamps can loosen, and the heater element on a plug-in unit can burn out. Fuel-fired units have their own fuel pumps, igniters, and control boards, all of which are potential failure points. That being said, high-quality units from reputable manufacturers are designed for harsh environments and are generally very reliable when installed correctly. Cost considerations. An engine air heater, as a factory-installed starting aid, has its cost baked into the price of the vehicle. As a standalone solution, a diesel air heater for cabin heat is generally less expensive upfront than a full-featured coolant heater. Their lower installation complexity also means lower labor costs. Coolant heaters represent a larger initial investment. The hardware itself is more expensive, and the installation is more labor-intensive, driving the total cost up. A simple plug-in block heater might be relatively inexpensive, but a programmable fuel-fired system can be a significant purchase. However, The value proposition isn't just in the upfront cost. One must factor in the long-term savings from reduced engine wear, potentially lower fuel consumption during warm-up, and the immense gains in comfort and safety. The bottom line. Let me put it this way. Choosing between an engine air heater and a coolant heater is about defining your primary problem. If your problem is, my diesel engine struggles to ignite in the cold, then an engine air heater is the direct, efficient, and cost-effective solution. It solves that one problem exceptionally well. But if your problem is broader, I hate everything about cold starting my vehicle, the wear and tear, the long wait for heat, the scraped windshields, the wasted fuel, then the coolant heater is the comprehensive answer. It's a system that doesn't just help the engine start, it transforms the entire cold weather operating experience for both the vehicle and its occupants.